Okay, so good evening, everyone. Welcome to Team One for Vancouver Datajam 2021. We are the Fitness Automation Tracker project, and along with all our team members. And as you can see here, our GitHub is also displayed. And this project idea was brought forward by Amal Tili from PyLadies. And there's a link here with the support of Nasreen Mohsin. So the agenda for today is the introduction, the goal and motivation for the project, the data, and then we'll be talking about the detection, conclusion, and some of the limitations and next steps we have for this project. So the goal of the project is to help a person who is exercising count the number of repetitions of a given exercise that they're doing. So by basically tracking the body posture as they exercise, and also to track that they can be used, that they can examine the movements that might cause injury. So the motivation behind this project is, as we all know, we're in this current COVID-19 pandemic, and with people leaning more and more towards fitness and a healthy lifestyle while staying at home. So to avoid further contact with strangers and to ease social distancing measures, we have come up with this project to help that. So along the way, we've learned about Python scripting and image and video processing. Next, please. So the data collection involved literature survey done on action recognition poses. We understood the body language decoder first through an AI video. We collected videos of curls, squats, exercises by pretty much all the team members and uploaded it to a shared Dropbox, and used the VM resource, which was greatly beneficial, approved by the Isaac team. And then we familiarized the date library media post, which detects up to 33 joints of the human body in real time. And as well as along the way, we have familiarized ourselves with the Google Colab. Next, please. So post data collection involved implementing a Python-based solution on counting the number of simple exercises. So we identified what libraries are needed and the respective versions. We created a requirements text file with the libraries, identified data sources basically by recordings from webcams, which you will see later on in the presentation. We recorded and collected 2 kinds of physical exercises for the Python code to parse and train. Next, please. So the data processing involved data feature extraction and storing in CSV. So basically we had 2 types of exercises that we chose, curls and squats. From each video, 50 frames containing Medipipe pose joints were recorded for each observation. So the 50 frames basically contained 1 to 2 seconds of exercise, enough for classification. And thereby, finally, we had a final CSV data file, which was on the LSTM model, which we used for training. Next, please. So we experimented, trained, and predicted with different models, which gives the best classification accuracy. And so whereby we pre-process the data frame from the CSV file and normalize the features for each observation set of frames. We split the data into training and testing, containing 21 curls and 20 squats. So the models that we used is a LSTM, long short-term memory model, and we trained it on Google Colab. And finally, we got a model accuracy of 93%. Next, please. So the goal of the detection media pipe was to implement counting code for squats and curls for each type of physical exercise pose. You can see the diagram here, which detects up to 33 joints of the human body in real time. We made the detection movement on the web app by our own machine webcams, which you'll see on the next slide. Thirdly, we calculated the angle and we applied the exercise logic to count the number of exercise sets that we were doing. So as you can see here, this is a visualization of the webcam recordings done by some of our team members.
The example that we are showing right now on the left-hand side basically shows how we can also run it on browser and not just pre-recorded videos. So the model is using the live video that we showed in the browser, and we will right now see how it can also detect the videos on the browser itself. The final video can be shown in the browser itself. So you can detect the poses and count the steps that we've taken.
Okay, so last but not the least, the limitations and next steps. We really thought that because of time constraints, we weren't able to delve deeper into the project. So that was definitely a limitation. We trained on a smaller data set. So for the future, we are looking to broaden our data set. We would also like to train our model on a larger data set at the same time with more exercise types other than just squats and curls, and also try different ML algorithms and also figure out if the exercise routine is done correctly. So these are some of our next steps. So thank you very much for listening. We are Team 1 Fitness Automation Tracker. Thank you for listening.
We can maybe go around and just say our names. So hi, I'm Srishti.
Hi, I'm Anna Jose.
I'm Sammy Ma.
I'm Amal. I'm Amal.
Hi, I'm Chloe Jo.
Oh, you're muted.
She's muted.
And I'm Nasreen.
And we also have Jason. We have some issues, but
yeah.
This was our team, and we really hope you liked our presentation. Thank you.
Thank you.
Thank you.